Okay, 10.3 is called Displaying Data Part 2. It really is just a continuation of 10.2. It's not any different. It's just they split it into two rather unequal portions. Actually, this one's shorter than the other one. It is weird. So we're going to look at a couple of different things in this section. The first one is going to be a line graph. A line graph has line segments connecting one data point to the next, typically showing the trend of a variable over time. And you should be thinking like connect the dots on the, like menus for the kids at the Chili's and stuff like that. Okay, connect the dots. And we're going to look at an example where it is over time. This is typically done over time for it to make sense. And we're looking at a learning specialist who's tracking the average reported study times of her students. And we're going to create a line graph for the data that we tracked. So our axis will look a lot like when we were creating like bar graphs and so forth. So we're going to have, let me get you smaller, our horizontal and our vertical axes. And of course, we're going to label them as we always do. The axis on the bottom is time, but specifically this is the day of the week. Right, the passage of time is what we're talking about. Whereas on this one's vertical axis, it's actually the hours spent, which is another time measurement, but it's the hours spent studying. Now, our axis on the bottom will be the days of the week. You can abbreviate if you'd like. So we've got Monday, Tuesday, Wednesday. They should be evenly distributed, at least approximately so. Thursday, Friday, Saturday, and Sunday. And then my vertical axis needs to represent the values that I have that are displayed here. So Monday is an hour and a half, Tuesday is an hour and 75, not an hour 75 minutes, an hour 0.75, 0.75 hours on Wednesday, and so forth. All of these seem to be in what kind of increments? 0.25. 0.25 increments, the smallest one being the Friday 0.25 one. So 0.25 increments is what I'm going to make my hash marks at. And so, again, I'm going to label about every other one just so that it doesn't get too messy, really. There's one. Here's 1.5. And then 2. 2 is my highest I need, right? Yes. Let me try and move this over just a little bit. Okay. And we're going to just put dots representing where each of these locations are. So as we're taking a look at this, on Monday, we spent an hour and a half. So on Monday, we're about right there. On Tuesday, it's an hour and 75, so 1.75 rather, and it looks like this. On Wednesday, we're at 0.75. On Thursday, we're at 2 hours. On Friday, we're lying, because I don't think we're really studying on Friday or Saturday. That's just my thought. It's a lie. On Thursday, we're studying for those tests that are happening on Friday. That's probably what's going on. And on Wednesday, we're at church. That's my scenario. Okay? And then the last one is that we're trying to make up all the time that we didn't do over the weekend that we should have done on Sunday. And we've got another hour and a half. Something like this. Okay, does that look good? And we're really just going to connect the dots. Okay, so it's going to look like this. We have to connect them in order, obviously, from Monday to Tuesday to Wednesday and so forth. And it would look like that. Now, this is sort of a weird one to graph this way. The ones that trend over time are usually something where we're expecting them to like trending, upward in an upward trend, or maybe we see a downward trend. We saw lots of trend lines showing up when people were tracking COVID data. You see trend lines when people look at the stock market. It looks crazy like this. It's a lot of up and downs, right? But trend lines are done, not trend lines, excuse me, line graphs. These are all line graphs. Strike the word trend lines. We're doing that in a minute. Line graphs. Line graphs are done to show change of things over time. So this is very common. All right, any questions on that? Oh, there's one thing we're missing. The title. We do need a title. What would the title or could a title be for this? Sure, average study time or study time spent. Something about the fact that we're studying average study time by students or something like this. Okay, so some variation of that for your title. Line graphs are pretty straightforward, pretty easy to do. Scatter plots start to be a little bit messier, and trend lines. So scatter plots are often used when a relationship between variables cannot be easily depicted, even by a broken line. Scatter plots are really used when, at least tend to be used more when we have a lot of data, at least the type of data that we're looking at. That's how we see them used. So my example is not a fantastic example, I will tell you that. But the example that I replaced it with from eons ago when I was first using them, I didn't like it either. I think this one's a little bit better, but it's kind of messy and it's hard to draw. So my example is that Coach Lewis, these are typos that I didn't get fixed evidently, I don't know. Coach Lewis kept track of the vertical jump heights. And it should say in centimeters. What does yours say? Anything at all? It says in centimeters. Great. So I probably just made my slide match yours. It doesn't say that. Put it in centimeters. Yeah. Put in centimeters in there. The height in centimeters, there should always be units measuring it, and it just got left out. And then it says over 7 years. And so then the last one is that I think there's a data value that I just have wrong on my screen. I think that first data value in 2002 at the bottom of it is actually 58 on your paper already, and it's just a typo on my screen, 68. Sometimes it's harder to fix typos inside of multiple layers of things inside my iPad, and it's just easier to just mark it. So sometimes that's the way it goes. Okay, we're going to graph all of this data, and it's going to look kind of messy. So kind of just to give you perspective, can you see my paper? We're going to have a whole bunch of dots. That's what we're going to be plotting. So if you flip over, I've actually got a grid on mine. You don't have to have a grid, but if you're trying to do these at home on some other ones when you're feeling like overwhelmed by the number of dots or something, get some grid paper. You can print it off from online. But I'm going to draw mine here on the screen. I say I am. Let's try it again. Okay, that's not bad. Along the bottom axis is typically still time. In this case, it's the years. So it's the year that we're looking at. So we have years. And this is going to feel a little bit funny, but follow my lead and you'll see why we want to do it later. We're going to make this years after a specific point in time, namely after the year 2000. It's going to make things easier in a moment. So what that means is that the y-axis, right, our vertical axis, is going to be the year 2000. If you want to write that in, you can to remind yourself this is 2000. And everything that I mark after that's going to be represented just by the units digit. So the year 2000, and then over here, I'm going to put the year 2002, so I'm just going to call it 2. And then I'm going to put the year 2004, and I'm going to call it 4. And then 6. How far did it go? 8 and 8. So 2, 4, 6, and 8. Or I might even make them spaced out a little bit more than that if you want to. In fact, it'd probably be easier if I do. So let me adjust these. No, I'm just going to leave them. We're just going to flip it. I don't want to adjust them. Okay. So we have values given to us, a bunch of values. It starts out with the year 2002. And what I want you to do is to look in this table. I want you to find the smallest value and the largest value because I need them in order to create this graph. What is the smallest value in the table? 58. What's the largest? 77? Okay, so I need to start at 58, I need to go to 77, but I can't just decide, hey, this is going to be 58, because the x-axis on the bottom, right, that I've already drawn and written on, is naturally speaking 0, so this makes it look funny, right? It looks like I go from 0 to 58 and I only pass through this one little unit of space. So if I choose to pass through a limited amount of space, what I need to do is I need to make a break in the graph, and that's what we're going to do. So we're making our graph look something like this, showing that there is a disconnect between x equals or y equals 0, which is my horizontal axis, and the values that I'm putting on my graph. So then I can start up here and I can put the 58. And I have a lot of values, so I'm just going to let one unit represent each one and label every other one like I have been. So this is 60, 62, 64, 66. I hope I have enough space. 68, 70, getting tight, 72. Need to go to 77, huh? Okay, let's do this. Okay, I think that'll do it. It's all off slightly. Let's fix that again. Okay. 74, 76, and at the very top I've got 77. It'll be okay. So this is 77 at the very top. It'll be fine. All right, so we're going to plot these points. So in the year 2002, I need to plot dots at the levels 65, 63, 60, 62, and 58. So it looks like a bunch of dots showing up on the same sort of vertical line. That's what it's going to look like. So if I have 65, it looks like that. And 63, and 60, and 62. Good grief. 62. And 58. So it should have 5 dots on each vertical line that I'm about to do, so vertical value. So the 2003, I'm going to plot them at 67, 65, 64, 66, 62. And then in 2004, I'm going to do the same thing, 67. So I told you it's a messy graph, right? 67, 68, 66, 65, and 64.
Why didn't we mark like 2, 3, 4?
What do you mean?
Because you said 2003, but you just did.
Why did I write 2 and why did I write the 4?
Yeah, instead of doing 2, 3, 4, 5, 6, 7.
Oh, down here, they are 2, 3, 4. I just didn't draw them in. So you can mark the hash marks for them if you wish. I just don't usually want to write as much because it's going to cramp in together because I've made it so tight and it's going to look really messy. I think it's easier to look at it and to see where I am without as much data written in. But marking the hash marks you could certainly do without it being a problem. Yeah. I did 2, 3, and 4. We're on 5 now, right? All right, so at 5, I've got 68, 70, 67, 66, and 65. And then in 2006, I have 70, 68, 67, 69, and 66. In 2007, I have 74. Somebody got some height on them. 74, and then 72, 73, 70, and 69. And my last year, 2008, I have 77, way here at the top, 75, 72. These are quite on the corners. 71 and 70. All right, it's not perfect. This is a scatter plot. I need to label a couple more things. What else am I missing labels on?
On this side.
Yep, so this is years after 2000. Let me shift that up since I went off my screen. The side, so what is the label I should be putting over here on my vertical axis? What are these?
That's the years, right?
Nope, the years are on the bottom.
Oh, the heights.
Yeah, so these are the vertical jump heights. Vertical jump heights in centimeters, like that. I need one more thing, a title. And the title actually ends up mirroring the y-axis pretty well. These are the vertical jump heights. And it's for Coach Lewis. Coach Lewis's basketball starters. Okay, this is a scatter plot. Please write down a note to yourself that says a scatter plot's just a bunch of dots, okay? Because what we're going to do next is we're going to overlay on top of these dots the next type of a graph. The next type of a graph is called a trend line. So the trend line is necessarily on top of or overlaid upon all of the scatter plot, but the scatter plot itself is what we've already done. Everybody good with that? Now, when you get to your homework and your group work, you're going to start out by giving you a picture like this. It may or may not have context, and they are going to ask you to draw a trend line. When you do that, what you're welcome to do is to take your sheet of paper and just put it on top of the book, and so that you can see where the grid line should be, you know, the X and the Y axis. You do not have to draw in all the dots. Just draw the trend line on top of your paper because it's almost like transparency paper, right? When you're doing it that way, or tracing paper, you can see through it, and you won't have to redraw the dots, okay? So for this one, though, let's take a look at what a trend line is. A trend line is a line that closely fits the data and can be used to describe it. It is often called a best fit line. It has no intention of trying to go through every single dot. That's not reasonable, right? We couldn't do that with the graph we just did. But what we're trying to do is we're trying to represent the trend of the data over time. So as you look at the graph that we just did with all the dots everywhere, clearly the graph is trending upward, right? Right? The jump heights are becoming more over time. We see that happening. So we want a trend line that represents that type of a trend. Now I'd like to show you how we draw such a trend line. So I need a line of some sort that goes through the data that sort of feels like it's in the same direction the data is, and it's balancing it out. Now, the truth is we are getting an approximation. It's a visual approximation, and that is all we are doing. And that's all that's appropriate at this level to do. In order to really, truly find a trend line, you actually need calculus to do that. That's not our goal here. Our goal is not to say this is exactly the trend line. It's to say approximately this looks reasonable, okay? So what does it look like? Well, let me show you a few things that it doesn't look like. So don't draw what I'm going to draw, and I'll undo them as I do it. It doesn't look like this. Although it looks like I've split the data in half, that is not a trend line, right? It does not look like what my data is doing. It looks too flat, right? It's not like this. Again, it looks like I'm splitting the data, but it don't look like, that's not what my data is doing over time. It's not like this either. Although that looks closer to what my data is doing over time, it's not splitting the data sort of into two equal parts. So I'm wanting to get a line that seems like it has the right shape, right? Like it's going in the right direction. That's called slope. But also that it splits the dots sort of about, approximately in half. So your trend line might look, and this is going to be an approximation that we would want now instead of something we wouldn't, might look something like this. You should look at that and it should feel appropriate. That's really what it should be. It's got the right shape. It's going in the same direction that all the dots are going, yeah? But it's also balancing, there's approximately, visually speaking, the same number of dots above the line as there is below the line. So, is my trend line going to be exactly the same as yours? Probably not. But is it going to look close? It should. Taylor? Oh.
Wait, never mind, you just answered my question.
Okay.
Because I was going to say, I spaced mine out more, so mine looks...
It will look flatter, but you're going to have a lot of the same, approximately the same points if you're just spaced out differently. Yeah, that's okay. Yeah, and we can actually make amends for that, Kaylee, with what we're going to do next. Because what we're going to do next in example 3, we already did part A, we drew the trend line, or approximately so, is we're going to create on part B an equation for it. So your equation and my equation will look close if you've got the same kind of a trend line, even if your spacing looks different. Okay? So thinking about lines, what is an equation, a basic equation of a line that you remember from algebra? Say it louder for me. Yeah. Y equals mx plus b. That's exactly what we want to look at. And if you'll remember, m is what's measuring the slope, and the b is where it crosses the y-axis. Now, I like the idea of it crossing the y-axis at the value for x being the year 2000 down here. All right, it's going to make it easier to write down my description here in a moment. So if yours is crossing at the year 2000 as well, it's probably somewhere close to the value of 58. Is it? Is what you drew close to 58? What do you get, Kaylee? Where's it cross yours?
I feel like mine would be like 61.
Okay, that's not far off. Where else are we at? Crossing the y-axis. Nobody else crossed the y-axis? Extend your line, cross the y-axis. Where are you at?
Mine was like 59.
59, Caitlin. Okay, good. Laura, where's yours at?
58.
58. Okay. So are we all sort of in the same ballpark? I don't want to say right, but in the same ballpark? We should be. Otherwise, our graph's probably not sketched very well. We should be close to one another. Okay. So as we're looking at my b value, it's going to represent, on my graph, it's 58. Whatever yours is what you should write down as your b value. Don't write down 58 if it didn't really cross at 58. Then you're just going to confuse yourself later. Okay. Write down what yours crossed. The next thing that we need is that we need to have the slope value. Okay, so the m and the b are what we're filling in. So how do I get slope value? Well, we're going to just take any 2 points that you wish, and you're going to look for where they cross on a corner. For example, my graph looks like it crosses at a corner spot right on the grid, really nicely right there. That's the y value on my graph of about 60. And I kind of want to just find the next location where it looks like it's crossing at a corner. And it looks like it crosses pretty nicely at a corner right here. Those 2 red dots are mine that I'm going to use. And I should just be able to count, right? Slope is a rise over run. So if I go from this dot to this dot, how much do I go up? Looks like 2. And how much do I go over? And it looks like 1. My slope looks like it's about 2. Okay? So maybe yours doesn't. Maybe you end up getting 1.75. Or you get 3 halves, right? You go up 3 and over 2 or something like that. So you get 1.5. Any of those are sort of reasonable values because they're all pretty close. So my slope seems to be approximately 2. So my equation is going to say y equals 2x plus 58. If that is what you write on a test or a homework question, you are going to miss substantial points. And here's why. I can't use that equation to do anything unless you tell me what x and y are. Because the x and the y are dependent upon where I decided to let the y-axis start and the x-axis start. And it's a problem if I don't measure that correctly. Are you tracking with me? Yeah? Yeah, I've got a problem if I don't measure this correctly. So right here where I've got the 2000 right here, that's telling me where my x values start. So over here when I write down my description, I need to say the x-axis is measuring the number of years after 2000. Now the y-axis is a bit easier on this one because I've put in this sort of break in the graph, okay? The break in the graph actually tells me that this graph is sort of like zoomed in on the top half, but it actually extends all the way down to the y values being 0 on the graph. So my y-axis value or my y values here really is the height in centimeters. And you really need to have the centimeters part. It's not in inches, it's not in feet, it's not in miles, it's in centimeters. It needs to be represented that way. Now, depending on how else you put, pieces of information in here, you might describe something differently. Maybe you didn't start your graph when you did it on your own for this problem, if you did it, right? at the year 2000. Maybe you really started with the year 2002. Okay, that's great. But your x value needs to say that then when you write your equation. Okay? So I'm saying this now, and I'm going to guarantee that only 2 of you maybe are going to do that when you get to your test. Because it happens every semester. And I harp on it just like this every semester. So highlight it. Do something so you're one of my 2. Or maybe it'll be more than 2 this time. That would be amazing. Without the details, x and y, and what they are, you cannot use that equation to do anything. For example, take a look at the next question. The next question says, using your equation, what would the jump height be in this year? Well, what year are we in? 2022. What would 2022 be the way that I've described x? 22, right? So if my x is being described as the years since 2000, then I need to make sure that the x value that I use corresponds to that. So my x is 22. And that's what tells me what I put into this equation now for the x. If you put in 2022, you're going to get a really funny answer. It's not going to make any sense because your equation wasn't set up to accommodate that. So this is still going to be a very large value. What do you get for the value if you put in 22? 102. 102 what? Centimeters. Yeah, 102 centimeters. That's a lot bigger than the values we got before. That may or may not be realistic. When we're working with trend lines, typically speaking, the further out you go from the data set that you started with, and this data set was from 2002 to 2008, the less accurate your values are going to be, right? Eventually things change over time as well, and they don't continue this way forever. But if you had estimated this, say, in the year 2010, your estimate would probably be pretty accurate. It'd be very close. But the year 2022, not as close. Does that make sense? Okay, the last pieces of information we have to do on this. This line, what can you tell me about its slope? Is it positive or is it negative? It's positive. It's going uphill, right? So if a slope is positive, we call that a positive association. And if a slope is negative, we call that a negative association. So we can do that from looking at a graph like we just did there. We could do that from looking at the equation we created right here, right? It's positive 2. We can look at that from an equation we're given as well. So in the first equation on number 4, is it a positive or a negative association? Negative, because the slope is negative. What about B? Positive. The slope is positive because the 4 is positive. What do you notice happening on C? There's not a slope. There is a slope. It's actually 0. Okay, so there's a slope of 0 is what we mean to say. If you were to think about rewriting it with that in there, it would actually say something like this, 0x plus 8. So if there is a 0 slope means you have a horizontal line, okay? And if you have a horizontal line, what that would have looked like, by the way, from your trend data or your scatter plot, is you would have had something that looks like this. Oh my goodness, that was a big fat dot. I don't know why that happened. Let's try that again. Right. There's no trend. It's just a bunch of dots. There's no pattern to it going uphill. It's going downhill. It's just straight through the middle of it. There's no trend. So when that happens, that's what we say, that the association is that there is none. Or you could say there's no association. So if you have a 0 slope or you have a horizontal trend line, there is no association for the data.